Hello guys and welcome to this lesson within the framework of TIA Portal Programming Beginner's Guide. Today, we are going to see how to use clock memory byte. We create a new project and give it a title. In this example, we use a 1500 CPU to simulate the program. Unlike in the 300 CPUs where PLC Sim is embedded in TIA Portal. With 1500 and 1200, PLC Sim is a separate software. It's worth mentioning that each version of TIA Portal has its corresponding PLC Sim. We click on Write PLC Program, but before we can access the programming interface we need to get a CPU from the device catalog. Well, we click on Add New Device, then we select the right CPU. In a real-world application the selection of the CPU depends on the order number of the physical CPU. In this example we are going to pick a 1500 CPU randomly since all we need is to simulate the program. We click on the main OB to start programming. However, to make a variable flash we need to enable the clock memory byte. Hence, we hover over device configuration. Then we click on properties and check the clock memory system. We tick Enable the use of clock memory byte. And by default the byte 0 which is activated and each bit of the byte is assigned with its own frequency. For the sake of not falling in overlapping memory issues, we change the byte number and make for example 100. Well, as we use a modular CPU we need to add a inputs and outputs modules. So, we head over in the catalog on the right and get digital input and output. Back to the main OB, and since the lesson aims at showing how to use flashing bytes, we are going to write a very basic program with a single input and output. When the input is active the output turns on in a flashing mode. To do so, we need to insert an open contact between the input and output and assign it with the address of a clock memory bit. As we can see, the role and frequency of the bit is shown as a name to the memory bit address. Well, we can rename our variables and move to simulation. No errors reported, we can therefore move to simulation. As we will see, the simulating the 1500 and 1200 is a bit different from the 300. Still the steps are the same. The main difference is PLC Sim for the 1500 and 1200 is a separate software that needs to be installed on its own. Here is the PLC Sim, the connection with TIA Portal is just getting started. We click on Start Search and wait until TIA Portal connects to PLC Sim. Some issues occur in this stage especially when connecting to the physical CPU. They are generally due to the type of the interface used. Good. The connection is established, we can therefore load our program to PLC Sim. Well, we expand the PLC Sim window to access the simulation environment. Then, unlike the old version here we need to create a project for the simulation. So, we click on the white icon here and create our project. We enter the project name. See that it is not necessary the project to have the same name as the TIA Portal one. Now, we click on Create and wait until the project is created. Watch out, the processing may take a rather long time. It depends on your computer performance. TIA Portal requires a sufficiently robust hard disk and large RAM space memory to work right. We open the sim table to access the table of variable. But before that, we need to be patient until the transfer of data is fully complete. Finally, we can now access the simulation interface. We open Sim tab and enter our variables. As you know, we have one input and output. When the input is active, the output is active simultaneously in flashing mode. We click on the icon here to enable the use of inputs and outputs, then we start simulation by pressing on the Run button on the right. Indeed, the output starts flashing just when the input is active. As a reminder, the purpose of this lesson is to show how to use clock memory byte. Hence we wrote a very basic example. Back in TIA Portal, we can see this properly. So, we activate the visualization to see the ladder logic response. Sure, we would not see this flickering line if we did not use the clock memory bit between the input and the output. Now, supposing that we need to speed up the output flashing. All we need to do is changing the frequency. As a result, we change the clock memory bit. We stop PLC sim and bring the right modification to the program. We switch for instance to the third clock memory bit, which is a 2 Hz, and see the result. As usual, it takes rather long time to process, especially for less performant computers. Well, we press on Run again to start simulation. As we see, the flashing frequency changed with the other clock memory bit. Anyhow, the flashing bits are mostly used in warning systems such as indicator lights, sounds alarms as a security measure. Thank you for watching, and if you like the video, make sure to give us a like to support us for further lessons. See you in another video.